gave you something to think about, which was this PIQ. A 20-ton truck moving left hits a 0.1 gram butterfly. Which of the following is true? Now I'm going to start a quick Google poll in our conversation, and I'll give you a minute or two. I want you to vote. Now, I don't think this works on mobile phones, but it works on computers. I'd like you to vote. Which answer do you think is correct based on your thinking since our last lecture? If a 20-ton truck moving left hits a 0.1 gram butterfly moving right, which of the following is true? The truck's force on the butterfly is larger than the force of the butterfly on the truck. The truck's force on the butterfly is smaller than the force of the butterfly on the truck, or both forces are equal.
Doctor,
أيوة.
we use the iPad, so where we can find the rule?
You can't find it. If you're using your iPad or your mobile phone, just type which answer you think in the chat, because it doesn't work. So we had problems with Moodle last week, which means I couldn't post these during the weekend. ولكن إن شاء الله من المحاضرة القادمة we will be back on doing the PIQs and everything on Moodle, so everyone can take part, even if you're on your mobile phones or iPads. Okay. I'll give you another minute before we start tackling هالمسألة العويصة اللي بالعادة تخلينا نطلع من المحاضرة وفينا صداع نصفي. Okay. So looking at the results in both the poll and the app and the chat section, we seem to have a split between option A and option C. Almost an equal split, I would say. Almost an equal number of people, slightly more saying C than those saying A. Now, that's a very, very interesting result. Can someone who chose option A tell me why did you choose option A? Why do you think the truck's force on the butterfly is larger than the butterfly's force on the truck?
Because it can't be C, because they're against each other, the directions. I mean, so one have to be positive and the other one have to be negative. Isn't that right?
Okay.
No,
What if we look at the magnitudes only? Only the number, not the direction.
the truck is heavier than butterfly, and the force depending the mass. The force is equal to ma. So the mass the key is in the mass.
Okay. That's good. That's good. What about someone who chose option C? Can someone who chose option C tell me why is it? Or did you just choose option C because Newton's third law says opposite and equal?
because we have in here two bodies, and these two bodies are interact to each other. So they're from third Newton. We have left.
Okay. So they have to be equal because Newton said so. Okay, fair enough. Let's do something. Since we have an almost 50-50% split, let's try something. I'm going to put you into breakout rooms where you can discuss with each other, because I know كلكم فكرتوا في الموضوع لكن فكرتوا فيه كل واحد وحده في بيته. طيب, without proper interaction. Also, we're very bored and we barely see our friends anymore. So let's try it out. We'll go into breakout rooms. I'll set a timer of about 3 minutes. Okay. And we will come back after this and do the same poll again. Let's see which side wins. Do the A's convince the C's that they are correct? Or do the C's convince the A's that they are correct? Or do we still get a 50-50% split? Let's see what we get. Okay, welcome back. Now I'll invite you to vote again, please, whether you think the correct answer is A or C. Okay. Did anyone change their mind from C to A? If anyone changed their mind from C to A, speak up. Was the reason that you were convinced that, you know, your friends managed to convince you that with a bigger mass, the force must be bigger? Okay. Did anyone change their mind from A to C? If anyone changed your mind from A to C, can you tell me what changed your mind? Okay, very quiet today. Okay. So before the PIQs, we had an almost 50-50% split between A and C. After the breakout rooms, after you discussed with your friends, we have almost 2/3 of the students are saying option C, and about 1/3 of the students are still saying option A. But unfortunately, so far, no one has been able to tell me why is it so, aside from, you know, Newton said so, which is a problem because if we are going to say something, we need to be able to explain it. We need to be able to stick by it. Okay, so we have now you can tell I have been putting a lot of effort into improving my drawing abilities. Okay. I actually did, you know, YouTube how to draw a butterfly, and this is the best I could come up with. So, okay. All right. So, a lot of us chose option C, which says both forces are equal. And what you're telling me is, okay, that this big ass truck and this tiny, tiny, tiny butterfly can exert the same magnitude of force on each other. Yeah. So, okay. In reality, when I asked you to explain how is that possible, most of you couldn't answer me or said that Newton's third law demands it. You're absolutely correct. But also, for example, Mariam in chat says, in reality, C does not make sense. And I agree with you. We have a problem let me be very clear. If you manage to get your head around the fact that these two things exert equal magnitude forces on each other from the first time you heard about it, well, you are doing way better than I did the first time I looked at this concept, because up until today, as an instructor, I struggle to explain this to students. Okay, so kind of tiny bit of me was hoping, you know, someone could give me a good explanation so that I don't have to. لكنكم ورطوني, for now I have to explain. Okay. Okay. We have our equation that F equals MA. Now, what does this equation tell us? It tells us that the acceleration and the force are related by mass. So for same acceleration, bigger mass gives us bigger force. But think of it this way. لما الشاحنة تضرب الفراشة، وش يستوي في الفراشة؟ ايش يصير في الفراشة؟ Yeah, you were saying something? Okay. So someone wrote تموت. Okay. بس في طريقها إلى الموت والسحق.
ترجع على ورا.
ترجع على ورا صح؟ وترجع على ورا بقوة. I mean, you know, we all watch movies. لما إنسان ينضرب بالسيارة يطير ورا كم 100 متر. زين، فما بالكم فراشة مسكينة اندقت بشاحنة بتطير. انزين، بالمقابل ايش يصير للشاحنه لما الفراشه تضربها؟
توقف.
ولا شيء.
nothing.
انزين، يعني بالعيره المجرده ما يصير لها شيء. the truck doesn't even ولا عندها خبر باللي صار. ها حد ضربني والله حلفوا. اوكي، الشاحنه ما عندها خبر. And this tells us something, that according to Newton's third law, these forces are opposite and equal. طيب آمنا بالله ما فيها إشكالية. But now if we fix the force, this means we play around with the mass and acceleration. So let me give you an example of a force of 100,000 newtons. If my mass is 20 tons, so 20,000 kg, what will my acceleration be? Can anyone divide 100,000 by 20,000?
Sorry?
5 meters per second?
Yes, 5.
Okay. What about if my mass is 0.1 gram, which means this is 0.0001, 1, 2, 3, kilogram. What would my acceleration be for the same force?
Million.
Million?
About
مليار.
كذاك?
اليوم.
There we go.
No.
بعد فيها أصفار زيادة؟
8 أصفار.
بعد 100 مليون يعني؟ 100 مليون.
1000 مليون.
Okay. 100 مليون 1000 مليون it's a huge number. صحيح؟ فما عندنا إشكالية. طيب ما عندنا إشكالية هنا because the mass difference is more than accounted for by the acceleration difference. Okay, the acceleration of the truck is nothing compared to the acceleration of the butterfly. Good? Ideas clear?
Yes, دكتور.
هذا نفس لما واحد مكرش يلعب مع أخوه الصغير ضربة كروش. هذاك مسكين الصغير يسوي فيه، هذاك ولا عنده إحساس. هذا مسكين يسوي ضربة واحدة، هذاك طار 5 أمتار ورا. Okay, so let's take a look at some forces. Okay. See, I have been on both sides of the equation. As a child, I was very, very thin. فطرت واجد. ولما كبرت صرت آكل واجد، فالحين أطير واجد. So أنا أحس بكل الجانبين من المعادلة. أنا I believe in equal access. So let's take a look at some forces, you know, that we experience on a day-to-day basis. Now, في الثانوية أو في الإعدادية, when we first started looking at forces, we defined it as a push or a pull. صحيح؟ So, how does this push or pull translate into different types of forces that we deal with on a day-to-day basis? Let's look. Can you hear me, by the way? لأنه هنا النت عندي يتقطع بين فترة والثانية.
Yes, doctor.
Okay, insane. Let's start with the most common force, gravitational force. ما في شيء على الكرة الأرضية، انزين، ما في شيء على الكرة الأرضية إلا ويحس بالgravity. And we said that gravity is always downwards, right? Now, when we weigh something, if إذا رايحين سوق الخضرة, you would see something like this. Okay, or you know, if you are fat like I am and you keep standing on the weighing scale every day on the toilet and hoping it's 200 grams less, okay, the scale can either be marked in weight or mass units. So it could either be in newtons or in kilograms. F equals ma for gravity, F equals mg. So when we are standing on a scale and we read, okay, your weight is 50 kilograms, what is the scale actually measuring?
The weight.
So the scale is actually measuring the weight, right? So the scale actually measures something like 500 newtons and then divides that, okay, by 9.8. So if it says your mass is 50 kilograms, what it actually says is, okay, I am getting 490 newtons. 490 divided by 9.8 equals 50 kilograms, and it will show you 50 kilograms. Okay. Okay, now here's a question. Newton's third law says, okay, and I've seen that quite a few of you were very confused by this in the reading quiz, okay, in the reading check. Newton's third law says each action has an equal and opposite reaction. Now, if I throw a stone from the top of a mountain and it's going down, what is the force on it?
Gravity.
Gravity, right? So mg. What is the Newton's third law force on it? Or by it?
My hand.
No, we're throwing it. It's now in the air. It's dropping. Is there any other?
Effect on the spoon. I didn't give it any acceleration.
So هذا الكرة الأرضية والحجرة جالسة تطيح وهي جالسة تجذب الحجرة بفورce equals mg. What is the Newton's third law equal and opposite reaction to it?
Normal force.
No.
Okay, but it's not actually touching anything.
Gravitational force of the stone on Earth.
Yes. So as stupid as this sounds, okay, the Earth is actually being pulled also by mg in the opposite direction. Okay, actually not mg. MA, okay, in the opposite direction by the stone. Okay, now again, so في حد هنا يريد يضربني. He's like, okay, الكرة الأرضية تسحب الستون، فهمنا. ستون كيف تسحب الكرة الأرضية؟ ما ينفع. نرجع لمثال الترك and the butterfly. إيش قلنا؟ قلنا Newton's third law. Butterfly hits the truck, truck hits the butterfly. Forces are equal, but accelerations are not equal, right? So while the acceleration of the stone due to the gravitational pull of the Earth is g, 9.8 meters per second square, what is the acceleration of the Earth due to the stone's pull? It's going to be 0.00000000000000001 meters per second square, maybe, which is nothing. Okay. Mariam, it's okay now? I see you had a lot of confused faces. Okay, perfect. All right. Normal force. Normal force, okay, is the opposite force to when two things are in touch. Okay, now let's look at this. Okay, this is very important. Normal force is not Newton's third law. Okay, a lot of people get confused between these two, between normal force and Newton's third law force, because, well, most times they're, you know, opposite, in opposite directions. Okay, but normal force is not a third law pair force. Okay, normal force is on the same object. So if you look here at the free body diagram, they are both on the block, the gravitational force and the normal force. The normal force is the reason when I put a book on a table, it doesn't go through the table, it sticks onto the table. Okay, because the book pushes down on the table, but the table pushes back up, normal force against the book, so the book stays there. Okay, now I have a question for you. If I have a ramp at an angle of 10 degrees, and I have a book here, what is the direction of gravity?
Down.
Vertical.
Vertically down, صح? What is the direction of the normal force?
Perpendicular to the surface.
Like this, right?
Yes.
Perpendicular to the surface. Now, this is another common confusion, okay? Because most of our problems are non-angled like this, we always see the normal force going up. And so quite a few students, for example, in the reading check, chose the option that the normal force is upwards, perpendicular and upwards. And the truth is, it has to be perpendicular, but it doesn't need to be upwards. For example, here, it's not upwards. Here, it's at an angle. Now, if you remember one of our older slides, had Spider-Man upside down, hanging off something. What would be the forces here? You would have gravity downwards. We agreed on that. Where would the normal force be in this case?
Downward.
The normal force would also be downwards, right? Because it's perpendicular to the surface. But then I have a question for you now. How is Spider-Man stuck to this thing? Now, he might be a superhero, but he still has to obey physics laws.
Tension.
So how is Spider-Man stuck there?
Tension.
Tension is a good option. Tension, surface tension, elastic tension, glue, something that gives you an upward force, which is equal to N plus mg. Yeah?
Yes.
Okay. Friction. Friction هو صاحبك المزعج اللي كل ما تريد تروح مكان يقول لك ما اريد ما اريد ما اريد، ولما تقول له زين انت وين تريد تروح يقول لك ما اعرف، لكن not any of the 2 million options that you gave me. Okay, that is friction. Okay, you want to go right, friction wants to go left. You want to go up, friction wants to go down. You want to go down, friction wants to go up. طيب, if you are not going anywhere, what does friction do? If you're not moving? Think of your friend.
moving.
يوم بعد 20 مكان خبرتيها وخبرته، انزين نبغى نروح يمين شمال، انزين كل مكان ما اريد ما اريد ما اريد. يوم you stop giving suggestions, you just sit there. Okay, you give me a suggestion. وين تريد تروح او وين تريدي تروحي? What's usually the answer?
ما أعرف.
Nowhere.
ما اعرف. somewhere. عادي. اصلا انا ما تفرق معي. Okay? This is
Anywhere.
okay? This is friction. If you're not moving, there is no friction. As soon as you start moving, there is friction. Okay. That is almost the correct definition. في تصحيح بسيط. Okay? في تصحيح بسيط. ما شرط انك انت تبدأ تسوق السيارة عشان صاحبك يقول لك انا ما اريد اروح المكان الفلاني، صح؟ اصلا من قال انك لازم تروح مكان؟ انزين، انت مجرد ما انت تبدا تفكر انك تريد تروح مكان يبدا يتحلطم، ما اريد ما اريد. اوكي؟ So it is possible for an object not to move but still have friction. اوكي؟ ما يخليك حتى تلبس ملابسك، من اول شيء يتحلطم. Okay? This is why we have here direction not of slide but of why is this not working? Not direction of slide, but direction of attempted slide. So even trying to slide before you actually manage to slide, okay, there is friction. And in the next chapter, in section 6.1, we are actually going to go through the two different types of friction and why do we say attempted slide. Okay, so the last one is tension. Now tension is a very, very, very loose term. Okay, in this course, most times when we say tension, what we mean is, okay, the force against some form of stretching. So for example, when we are pulling a rope, لما نلعب شد الحبل مثلا، أول شيء الحبل مرتخي. But as soon as you start pulling it, the rope becomes very, very tight, right? That tightness in the rope is what we call tension. Now, this tightness here, and in most examples, if not all examples in your book, will be due to ropes. But I'll give you one more example. Okay. Actually, I want to do this. I am sorry if you don't like insects, but at the time being, this is really, really the best example we have. Have you ever seen an insect like this on water?
Yes.
اوكي، شوفوا على رجول الحشرة هذه، على الأطراف، على سطح الماء there is something كأنه كذا دويرات. هل لاحظتوا هذا الشيء سابقا؟
Yes.
probably لما بالعادة نشوف حشرات أول شيء ندور عليه هو الزنوبة. We don't really take time to look at what are they doing on water, but we can take a look at a photo and we'll see that at each leg, at each limb, at each end, we have this like a tiny circle in water. Okay, now let me show you something else. Take a look at this photo. Look at the edges of this water drop. Now take a look at this when a drop forms. Okay, look at the progress and look at the very end when it finally detaches. Okay, have you ever wondered why are water drops always spherical in shape? If you look at the edges of this photo, can you see anything specific? Can you notice anything specific at the edge of the circle of the water drop?
They are smooth.
They are smooth. They're not only smooth, they are tight. Like the rope. When we pull it, the rope becomes tight, right? This looks tight. When you're trying to move your little brother or little sister on a bed sheet, okay, أو على فوطة كبيرة, you put them, they make a dent. The bed sheet or the فوطة becomes very, very tight in that location, right? Now in that photo we saw of the snake, of the insect, okay, the water looked like there's these, circles at this foot. It looked like the water there is tight, okay? And that is what we call surface tension. Okay, this is what we call surface tension. The reason water drops are always spherical, or the water is tight at these three reasons, is because of what we call surface tension of water. Okay, it's the same مع اللعبة هذه اللي كنا نلعبها ونحن أطفال مال صوابين، صابون وماي وبعدين ننفخ في هذيك الدويرة وتصير كلها فقاعات. الفقاعة spherical. You can see the tightness on its edges. Okay, so these are all examples of tension. Okay, now most times in this course we'll be dealing with tension in ropes because it's the simplest of types, but I just wanted to inform you that there are other types of tension. Okay, it's not only ropes. There are many other types of tension. Let's take a sample problem and do it together. Okay, quite a few people said we have problems with sample problems. Quite a few people have emailed me asking me to do more examples in the lectures. So let's try to do that today. Here's a sample problem from your book. In figure 5-15a, a cord pulls a box of sea biscuits up along a frictionless plane. Okay, I don't like sea biscuits. Nabil biscuits. Up along a frictionless plane, inclined at angle theta equals 30 degrees. The box has a mass of 5 kilograms, and the force from the cord has magnitude 25 newtons. What is the box's acceleration A along the inclined plane? Now, what is the easiest way to do this? Or what is the procedure we should be using to solve this problem?
We have to draw and put the detail.
Okay. And then?
Find F net by all the forces together.
Good, good, good. Okay, so let's do that. First thing first, we draw all the forces. I have my gravitational force downward. I have my cord pull, the tension, along the rope. And to the top, we have our normal force. Good. Now, do all of these forces play an equal role in determining the acceleration? ولا في بعضهم لا؟
The acceleration of the box will depend on the forces in the same direction.
Now, remember, we have an x-axis and we have a y-axis. صحيح? Now, we said the x-axis and the y-axis are upset. So if anything is at 90 degrees, it's not going to not going to
affect each other.
Affect the movement in the other axes, right? Now this box will move in this direction, right? Up or down. It will not go this way. So anything in the y-axis ما ينحسب. So let's do something. First thing first, we resolve our forces into components. So I have my mg going downwards. I will resolve it into mg cosine theta and mg sine theta, like this. Mg sine theta is going to be along the ramp. Mg cosine theta is going to be vertical. Then, the only thing that affects the movement will be mg sine theta and t, because Fn and mg cosine theta are in the y-axis. So, net F equals ma. Net F is t minus mg sine theta, opposite directions, equals ma. Is it okay if I write mg sine theta minus t equals ma? Is that okay or not?
Yes.
Okay, a couple people wrote no. One person said yes. Why yes and why no? Anyone? عسانين اليوم.
The box is going down or up?
We don't know where the box is going. We want to find its acceleration. We still don't know if it's going down or up. We know that the rope is pulling it with 25 newtons, and we know that its mass is 5 kilograms. That's all we know. We don't know if it's going up or down. ايش قلنا لما كنا نتكلم عن الجرافيتي واي بلس جي ولا ماينس جي؟ قلنا انه we decide which direction is plus and which direction is minus. It doesn't really matter, right? And this is the exact same thing now. It doesn't matter which direction is up, which direction is down. Okay, now, if I decide that this direction is positive and this direction is negative, I will write plus t minus mg sine theta equals ma. Then I look at my answer for A. If my answer is positive, this means it's going up. If my answer is negative, it means my box is going down. صح؟
Yes.
طيب.
Yes.
On the other hand, أنا ممكن أختار شيء ثاني. أنا ممكن أختار أنه تحت positive وفوق negative. Okay. I still have mg sine theta. I still have t. In this case لما أجي أكتب إيش راح يصير؟ إيش راح ينكتب عندي؟ لما أجي أكتب المعادلة راح ينكتب عندي plus mg sine theta minus t is equal to ma. مرة ثانية أشوف على ال A. إذا كان ال A positive وإذا كان negative. إذا كان positive الحين نحن وين عرفناه positive؟
Down.
Down. وإذا كان negative up. Very simple. Very, very simple. So, let's take a look. We will do it both ways. Our tension was 25 newtons. M was 5 kilos. G is 9.8. And the angle was how much? What was the angle? 30 degrees? 30 degrees. Can someone do for me 25 minus 5 times 9.8 sine 30? Uh, 25 minus 5 times 9.8 times sine 30 degrees divided by my mass, which is 5 kilos, will give me an acceleration of 0.1. It will give me an acceleration of 0.1 meters per second square, which is positive, which we have defined to be up. So it is going at 0.1 meters per second square in acceleration towards the top. What if I decided to do the other way around? So I will do this minus 25. So mg sine theta minus 25 divided by m. And my answer is going to be minus 0.1. So if I do this way, I will get, if I do it this way, I will get A equals minus 0.1 meters per second square. And by our definition, minus is in the up direction. So our answers are actually the same. So here it is 0.1 meters per second square up. And here, this is the same as saying 0.1 meters per second square up. وضحت الفكرة؟
Yes, doctor.
Good.
Doctor,
Yeah.
I have question.
Mm-hmm.
If we take cosine theta and we take the second angle, it's correct?
So cosine with 60
With
degrees.
x-axis. With x-axis, yeah.
So cosine and with 60 degrees with the x-axis. That will give you the exact same answer.
Okay.
So why theoretical? Let's try it out. I will change cosine, sine to cosine, and 30 to 60. And it should give us the exact same result. See? Minus 0.1. Yeah? It's very, very flexible. It's very, very flexible. Okay. Okay. Let's do another PIQ. Which one is this? PIQ 4. We have 5 options. PIQ 4. Option A, option B, option C, option D, option E. Okay, so consider 3 cases shown in the drawing. Same force F is applied on a box of mass M. Okay, in which case or is will the magnitude of the normal force on the box be equal to F sine theta plus mg? Remember, the normal force, because this block is neither floating nor sinking, the normal force has to be equal to whatever is downwards forces. The case 1 only, case 2 only, case 3 only, cases 1 and 2, or cases 1 and 3. We have C's, we have E's. We have a couple of D's. But most people are saying C, which is cases 1 and 2, case 3 only. So let's try it out. Case 1, we have force going up. We have mg going down. We have normal force here, which will be equal to mg cosine theta, or mg sine theta. So not this. So anything with case 1 is automatically wrong. So not this, not this. Let's look at case 2. We have mg down, we have n up, which will be equal to mg plus, so we are at a good start. And now we have f in this direction. Now this is our angle. Cosine adjacent, opposite. So this would be f cosine theta, and upwards would be f sine theta. Case 3, on the other hand, would give us mg n equals mg plus, or actually, yeah, this is this way f, which means we have mg cosine to the right and mg sine down. So n has to equate what is down. So in this case, we will get n equals mg minus f sine theta. In this case, we'll have mg plus f sine theta. So case 3 is okay, case 2 is not okay. So the correct answer is indeed option C. Okay. Well done. Most of you got it correctly. We already discussed this. Let's see. Okay, so we have a man who is in a lift. Okay, and the lift is moving. Now, this will be PIQ 5A, A, B, C, D, MA plus MG, MA minus MG, MA, MG, 0. Then we will have PIQ 5B, we will have A, we will have B, we will have C, we will have D, we will have E. Okay. Let's start the first one. A man standing in an elevator. The elevator is accelerating upward with acceleration A. The reading on the scale is what? Is it MA plus MG? MA minus MG? MA, MG, or 0? Now remember, the scale is actually measuring your normal force. Okay, you are standing on a scale, you are putting Fg on it, and it will measure how much it needs to push back on you, which is Fn. This is my passenger. The elevator is accelerating upward with acceleration A. So we have mg downwards. We have ma upwards. And we have our normal force. Most people chose option 1. Let's see. My normal force will be measured as mg minus ma, which seems to be giving us a problem because that is in none of our options. So let's find this man who is in an elevator. So I have a question for you. What was my mistake here? I obviously made a mistake. So what was my mistake here?
Reverse the signs.
Okay, but why did I make this mistake? Why did I reverse my signs?
Because it goes upward.
So the question says the man is standing in an elevator. The elevator is accelerating upwards. So my MA is upwards. So why, when I wrote N, MA, MG, and I just followed the arrows, I made a mistake. I end up with the wrong answer. Why?
Change the G and A.
Victor, you just take the force of elevator, but the man normally is opposite of direction.
Excellent.
هو الرجال بيأثر بعكس قوة المصعد.
Excellent. Very well said. Very well said. I looked at the wrong component of the system. Okay. While the question is about the scale, which means about the man, I instead looked at what? At the elevator, at the lift, which ended up me doing the wrong thing. Newton's second law says F net equals ma, right? So ma is equal to my gravitational force, mg, minus my normal force. Or did I make a mistake again? Why am I unable to get it right? If I rearrange this, I will still get mg minus ma. No, are we stuck?
Plus and because you go up.
But when I did it now, لما أنا سويته, Fn is up, Fg is down. So what did I make? Where is my mistake?
mg is minus while n is
Yes, mg minus.
I did not stick to my own conventions, right? I did not stick to my own conventions. When I started, I did not choose which direction is up and which direction is down. And that caused me a problem. If I choose this direction is up and this direction is down, and I am saying MA is up, it means I need to say minus mg plus n. So it gives me n equals ma plus mg. This is correct. My mistake was I did this. This is what I wrote. ma equals mg minus n. And this has a big problem in it because this says, okay, so because this says, okay, that ma is up and mg is also up, and this cannot happen. This is a problem. Are you clear where I made the mistake?
Yes.
Another man stands on a scale inside an elevator that indicates his weight is W when he is at rest. What will the scale read when the elevator is moving upwards at a constant velocity V? Last question of the day, and then we can all go home. Well, we are home. We can just go rest. I'll give you a hint. Read the question very, very carefully. There's a trick in it. We have a few A's, a few C's. Many C's. Some E's. Good. Most of you got the correct answer, which is C. Now the trick in this question, oh yes, I know I'm presenting. The trick in this question is, it says the elevator is moving upward at a constant velocity c. If the velocity is constant, what is our acceleration? 0. And we said the scale measures m, which is ma minus plus mg. So if my acceleration is 0, that means n is equal to mg, which is exactly w. So whether we are moving at a constant velocity or we're not moving, it's the same thing. Cool. We are done with chapter 5 and with our lecture for today. Next lecture, inshallah, we're going to start with 6.1, which is our second chapter on forces, and we'll start by looking at friction.